we're excited to talk about RISE to you today. So you've been hearing about RISE a lot, and we have the lounge out in the hall. So what is RISE? RISC-V Software Ecosystem Collaboration. At Rivos, as a RISC-V startup, what we have realized past couple years is as we work through the different parts of the software stacks, we're coming across with our other ecosystem partners working on the exact same thing. So only to realize when we upstream the patches, the same effort is going on in the other side with other partners. So co-travelers like Google, Sci-Fi, Ventana, we came together and say, how could we look at these duplications of efforts and get the most mileage of our resources as well as our investment? And that's how RISE collaboration effort was formed. Today, we're going to take a look at RISE was launched 6 months ago. We're going to tell you what we've been up to past 6 months and how we're looking at 2024 and how the team is structured, what we could do to best collaborate as the ecosystem. Our objectives, it's very simple. We want to make sure software stacks for RISC-V architecture is on par with other architectures that exist today. We want to gather our resources together to accelerate our software readiness for all segments. That could range from automotive, as they talked about earlier, or I think there's an echo. All right, so let me stay here. Okay, great. So getting our software efforts in the accelerated pace. We're all working on it, but how do we go faster and more efficient way and not to duplicate our efforts? What are we doing to achieve these goals? First and foremost, RISE is open and transparent team. You can find all of our projects on the wiki riseproject.dev. What we are planning to do, what are the projects that are identified as the current challenges that we're planning to tackle. Anyone in the ecosystem can submit projects, and RISE members will take a look at and prioritize what gets done first and how we are slowly going through this long list. These are our current members. All of these companies came together as a shared goal of accelerating our software efforts. What do we bring to the table? 2 things, resources and funding. From resources perspective, we're getting our engineering talents together and leverage different expertise in different parts of these companies to tackle all the different problems we're identifying in different parts of software stacks. Whether that's kernel, software, or language runtimes. And the second piece is the funding. We're allocating some funding to the ecosystem for the parts that we're unable to do ourselves. We're looking at you as a developers to come help and solve these challenges. And as you can see, the members range from RISC-V startups, platform companies, device companies, so all different parts of the ecosystem is coming together. This was a slide from Callista's keynote back in Barcelona in June, RVI Summit. Where does RISE fit in the ecosystem? We have the RVI doing a great job leading the charge to do the standardization for the ISAs. RISE is basically looking and joining you as the developers to mature the software stacks. Okay, this is probably the most interesting part to you as a developer. As we came together in the past 6 months, we have identified 3 pillars as the technical areas that we need to tackle. First, platform, developer tools, libraries, and middleware. On the first platform side, this is including emulators, simulators. The team is already busy at work. Kumar is going to cover more details on this aspect. And development tools is the kernels and the compilers and tool chains. And we're already working on vectorization of LLVM and GCC on this space. From the libraries and middleware, third pillar, optimizing language runtimes like Go, OpenJDK, and Python. This team is also looking at looking at publishing RISC-V architecture optimization guide, and we'll be making this publicly available so we can all collaborate together. To enable these 3 pillars, we also have 2 different efforts kicked off in parallel. One, developer environments. We have enabled Google Cloud instances for the developers to take advantage of so that your patches and your updates environments go faster. We're seeing great usage on this one. And as the hardware is pretty scarce in the ecosystem, we're also looking at how best to enable hardware with the ecosystem. I think Nathan has some stuff to cover on this one. Then request for proposal, RFP process. We have the 3 pillars identified gaps, and we have our engineers and resources working on some of these gaps. Another way we're solving these challenges is looking to you and how you can help to contribute. Basically, we kicked off request for proposal process, and you'll be able to see this on what are the identified projects, and as a developer, so you can bid for those projects as well, and the RISC-V members will select who to work with and invest in those spaces. So this will be something Nathan will go into deeper. To achieve those goals, as well as be more efficient, we have structured the team in this way. Governing board consists of all the premier members representatives, chaired by me and Amber Hoffman from Google. We have a project hosted by Linux Foundation. They are ensuring we're in compliance and helping us with day-to-day operations. We also have our great marketing team looking to work with you and broader community to ensure how best to collaborate. And most importantly, our technical steering committee, which is chaired by software experts from Google, Google, Ventana, and Rivos. So this technical team came together and identified roadmaps. I think we're missing the roadmap slide here, but yeah, so you're going to cover that.
Okay, so can people hear me? Okay. So I'll cover the TSC and the working groups as you see here. And amongst the 3 of us, we are the joint co-chairs. So there's Andrew, who's sitting right in the middle there, and then there's Nathan Egge and myself. So we are the 3 joint co-chairs of the TSC, which is the Technical Steering Committee for RISE. And there are 9 working groups, as you see here. And the way we have divided these up is each person kind of governs 3 of these working groups, so that there is equal division of roles. So myself, I cover the platform level there, the first horizontal that you see there. So that consists of the first working group is Linux kernel and virtualization. Each of these work groups has a work group lead, and the lead is responsible for driving the daily activities, the various projects, how the things get reported, how the status is managed, and everything is driven by that lead. So Anup Patel is the lead for the Linux kernel virtualization. Then we have system firmware. Sunil is the lead for that. And simulators and emulators is the third one. Daniel Barbosa is the lead for that. Then in the second tier that you see, that's developer tools. Andrew governs that horizontal there. And the various working groups falling under that horizontal is compilers and tool chains. Jeff Flaw is the lead for that. Linux distro integration, which is under Brian Redbeard Harrington from Red Hat. And debug and profiling is under Fei Wu. And then libraries and middleware is the third horizontal, that's under Nathan. And so that consists of language runtimes. Ludovic is the lead for that. And system libraries, Nathan himself is the lead for that. And dev infrastructure, which is under Paul Walmsley. And so as we mentioned before, you saw the wiki page. So each of these work groups has their individual wiki page. There's a list of detailed projects that are being done, what is being planned for the future. And that's what we'll talk about in the next few slides. So we won't cover everything that is being done today, but we'll cover some of the key highlights that we have done in 2023, and then moving into 2024, what is the roadmap for 24 as well. Okay, so let's start with the way these next few slides will be structured is that we talk about the 2023 highlights, things that we got done in 2023, and then 2024, what does the roadmap look like? Right, so starting with Linux kernel and virtualization, bulk of the work this year was in enabling basic ACPI support and vector support in the kernel. And then there is still work going on for AIA and IOMMU patches. They are still up there. They haven't yet been merged in. So that is work that is ongoing. And then there is native and hosted debug as well. So on KVM, on the virtualization side, things that were done were AIA in-kernel IRQ chip support and vector virtualization as well. And the IRQ bypass feature is still ongoing. Moving to 2024 on the Linux kernel side, still continue with ACPI improvements. There's a lot of work still to be done for ACPI. So those would be primarily in the areas of power management, like LPI, CPPC. There's also the RAS framework that is freezing and that will be frozen shortly. So that will have to be brought in into the Linux kernel as well. So that's something we'll do in 2024. There are SBI v2.0 and v2.3.0. So they are some features that we need to bring in into Linux as well. So those are things like steal time accounting, then there is system suspend, debug console, and there is PMU snapshotting as well. And then SBI 3.0 defines some supervisor software events that we need to implement in Linux. Moving to KVM, nested virtualization. So that's something that has been going on for a while, but there'll be more focus for nested virtualization and acceleration in the first half of 2024. And then on the SBI v2.0 and 3.0 features as well. So the same thing that we are doing on the kernel, we'll have to do it for KVM as well on the virtualization side. Moving to system firmware, on EDK2, we got Clang supported, which is great. And then SSTC, MMU, cache management operations, the multi-arch UEFI package is integrated in EDK2 today. Standalone MM is ongoing, so we don't expect this to be done this year. This will carry over to next year. And we'll continue this in 2024 as well. OpenSBI, we've added sparse ID support. And then U-boot, we added PCIe pass-through as well. And then the TFM, which is the trusted firmware, and M mode, that is work that has barely started. This will continue into 2024 as well. In 2024 priorities, RAS is important. As I mentioned, the spec is starting to come close to being stable. And that would be added into the firmware as well, as in terms of like a firmware-first approach. And then EDK2 will continue with backtrace. We'll have UEFI, the payload package, and then standalone MM will continue. And then there is dynamic tables package as well. And then TFM, as I said, would continue as well in 2024. Simulators, emulators, most of the work has been in QEMU. A lot of work is complete. ACPI support for the interrupt controllers, PLIC and AIA, virtual IRQ, Linux hardware probe, the query CPU implementation, and vector crypto. So all of those are available in QEMU today. And things like profile support is still in flight, and the IOMMU is still in flight as well. So that's an important one that will again continue into next year as well. In terms of 2024 priorities, vector emulation, performance improvements, and then WorldGuard, which is coming up, and then IOPMP will be implemented in QEMU in the first half of 2024. Moving on to the next one, so I'll cover this one as well. So on the developer tools horizontal, there are 3 work groups there. The most important one probably is the compilers and tool chains, and then we have debug and profiling, and then distro integration at the bottom. So for compilers and tool chains, auto vectorization was a focus in this half of the year. Will continue to next half of the year. A lot of work still remaining to do there. So that would continue. So a lot of the basic implementation of auto vectorization in both GCC and LLVM is there today. But the work in terms of improvements would continue in 2024. We added extension support for some extensions like ZICon, ZFA. Atomics, general, overall better atomic support was added in GCC as well. And the removal of redundant sign extensions, address arithmetic, backtracing support was added. We now also have the ability to build binary toolchain package releases. So that is something we accomplished this year. And then in terms of instruction fusion, that is work that has just started, and then large code model support work is still ongoing. Moving to 2024, so as I mentioned, auto vectorization improvements and optimization of CRC functions. There is stack clash mitigation, long branch support, and lastly, inline expansion for memstar or string star functions, right? Memcopy, memset, string copy, and those operations related to string manipulation. So those would be inlined. So that is work we'll take on in 2024. Debug and profiling. So primarily addition of vector support to Valgrind. This has been going on in 2023. We expect this to flow into 2024. And address sanitizer support. And then on the distro integration side, work pretty much in unifying various boot elements, grub support within Fedora, Ubuntu and Tizen as a distro. So we are glad to have Canonical join RISE as a member. So we have Ubuntu representation as well. And going forward, we expect to have more of these OS vendors join RISE. So in terms of overall ecosystem completion, that's a great step to be in. And that's it from my side. So I'll hand it over to Nathan.
Thank you. Can you hear me? Excellent. So I'll be covering the libraries and middleware section. So we're kind of moving a little bit further up the stack now. And what that means is that we actually have. Can you hear me now? All right, thank you. Yeah, so I'll be talking about the libraries and middleware horizontal. And so this basically covers, as I was saying, a portion that's much further up the stack, right? So now we're talking about a lot more breadth in terms of the ecosystem and all the different participants. On the language and runtime side, that working group identified essentially 4 high priority runtimes that need to be optimized for RISC-V. And so in order, there were the Java, the OpenJDK runtime, Go, Python, and .NET. And so for the Java, the success there was that they were able to get the work that was done in Java 21 ported back to JDK 17. That's the full complement of garbage collector plus other features. And that runs on, that's legit with it goes to native code. For the long-term support, Java 21, Java 17, and Java 11 are the targets. They're not going to target Java 8. And those currently patches in flight to backport those features to Java 11, so you'll see that coming. They also added hardware feature detection to the OpenJDK, and they started adding optimizations, so you'll start seeing things like vector being detected and used. On the Go project, similar work is done there. That actually runs and has hardware feature detection. As was discussed earlier, one of the places we're looking to use the community to help us is through an RFP to do additional optimization for the Go runtime. So that RFP went out. We got some participation, and someone was selected, and they'll go through adding crypto, vector, and a bunch of other important instructions there. For all of these, one of the things that's a real concern for us as a community is that getting just the runtime working is not enough. There are a lot of other packages that are dependent, that are used as part of these ecosystems, and those packages have a lot of native code, right? So it's not just sufficient to have a jitter that works. We have to actually reach out to the community, get them excited about RISC-V, and get them thinking about how to port those libraries. Now, if you think about certain deployments of jar files, they have native code in them. We need that native code to have Linux SOs for RISC-V. On the system library side, we have a similar problem, although it's even maybe more challenging. Currently, you can run RISC-V, Linux RISC-V, and build basically 99% of all the packages that are in a Linux distro. They're C code, they work fine. Getting them optimized and up to the same performance as other ISAs is actually quite challenging. It's going to require reaching out to a bunch of developers. And so what we did in the system library side is we picked a couple of core projects, did the work to optimize them, and then documented that and produced both a developer guide of some of the optimization work. We did a case study of how you add RVV to a multimedia library, and we produced a turnkey developer environment. I'm going to move forward here. The other working group in this vertical is the developer infrastructure working group. And this basically is designed to address the need of both members of RISE and the broader open source community needing basically cloud runners for, or basically services and software for testing and compiling upstream projects. So the first area that was identified was the Linux kernel, and this group has added pre-commit CI to the Linux kernel, basically checking to make sure that patches compile and work fine on RISC-V before they're landed. They've also added CI for the GCC project, and we're in the process of maybe productizing that, turning that into a formal offering and thinking about how we can extend that to other folks. So I'm at 1 minute. What I'll do is I will say, if you'd like to learn more about this, there'll be a talk about this developer infrastructure work at the Linux Plumbers Conference on Monday, the 13th. I also wanted to give a little bit of information about the RFP process. So very, very briefly, when we identify a need, we'll put out an RFP, and that will go out on our wiki and on social media so everyone will know about it. You'll be able to submit a bid. We will review those bids. That'll get approved by the governing board, and then there'll be a contracting process. All of that's going to be run through the tech leads for the working group, so they'll be the one that you would liaise with. And currently we've got 3 projects kind of in flight. We've got the Go runtime I mentioned. We're working on libjpeg turbo, and we've got a multimedia one that will look to do optimized 264 decoding. And so finally, please join us. The success of RISE really depends on the members. The members set the priorities and the direction that we go in, and we would really like to have additional participation to make sure that we cover all of the important industry use cases. All right, thank you.